Now moving on to question number 2, we are given 2.1. The first term of an arithmetic series is 7. The common difference of this series is 5, and the series contains 20 terms. And question 2.1.1 reads, calculate the sum of this series. So this is an arithmetic series. We have our first term, A, which is equal to 7. We have our n, the number of terms, being 20. And we have D, our common difference, being equal to 5. And we know that this equation for the sum of an arithmetic sequence of an arithmetic series is n by 2, open bracket, 2a plus n minus 1 multiplied by the common difference d. And in this case, our n is 20, so it's going to be 20 divided by 2, open bracket, 2 multiplied by a is 7, plus n minus 1, our n is 20, so 20 minus 1, multiplied by d, which is 5, and then it simplifies to 20 divided by 2, that's 10, multiplied by 7 multiplied 2, that's 14, plus 20 minus 1, that's 19, 19 being multiplied by 5, which simplifies to 1090. So that's it for question 2.1.1. Now question 2.2.2 goes on to say that the original arithmetic series is extended to 75 terms. So in other words, we started with 20 terms, now we have 75, so we have added an extra 55 terms. The sum of these 75 terms is 14,400. Using sigma notation, write down an equation for the sum of the terms added to the original series. So they want a sigma notation for the 55 additional terms that were added to the 20 original terms. So let's go back to our equation, to our series of 20 terms, and we know that the general form of our series will be a plus n minus 1 multiplied by d, a plus n minus 1 multiplied by d, and our a is 7 plus n minus 1, and our common difference is 5. So let's not replace the value of n, because now we want the general formula of this arithmetic sequence. So let's simplify this. This one will be 7 plus 5 multiply n, that's 5n, minus 1 multiply 5, that's negative 5, and rearrange and simplify, it will be 5n, 7 minus 5, that's positive 2. So this is our general formula for our arithmetic series. Now we can simply use the same general form, so 5n plus 2, but now we don't start at n equal to 1. We are going to start from n is equal to 21, because initially we had 20 terms and we added 55 additional terms. So we are going to start from n is equal to 21 until n is 75, and this becomes the general form of the additional 55 terms which were added, and this will be equal to the sum of the 75 terms. In this case it was 14,400 minus, so we have 14,400 minus the sum of the first 20 terms, which we calculated here, 1090, and simplifying this will give us 14,400 minus 1090 13,310. So 13,310. So this is the answer for question 2.1.2. 2.1.2. Let's move on to the next question. Now moving on to the next question, which is question 2.2. It reads, the sequence of the first differences of a quadratic pattern is 1, 3, 5, and so forth. 2.2.1 goes on to say, if the 99th term of this quadratic pattern is 9,632, calculate the value of the 98th term. So what we are given here are the first differences of the quadratic pattern. So we have our first term, second term, fourth term, until we reach term number 98 and term number 99. And our first differences are 1, 3, 5, and so forth, with our second difference of 2. Now, if we take the first differences, 1, 3, 5, and so forth, we can see that they are forming an arithmetic sequence. So, if you take 1, 3, 5, so if you take 1, followed by 3, followed by 5, you will see that the difference here, which is 2, there's a common difference of 2, which means our Tn, the pattern only for the first differences will be A1 plus N minus 1 multiplied by our difference, our common difference, which will be the first term being 1. So with 1 plus N minus 1 multiplied by D, which is the common difference of 2. Simplifying this gives us 2 multiply N, that's 2N, minus 1 multiplied 2, that's negative 2, which can be simplified into 2n minus 1. So this is the general pattern. This is the general formula for the first differences of our quadratic pattern. Now what this means is, if we are, how did we get this one, the first difference? We can go back to our pattern and use 2n minus 1 to get these first differences, 1, 3, 5, and so forth. So if we are to use 2n minus 1, so to get this one here, we said 2 multiplied by 1 minus 1. 2 multiplied 1, that's 2 minus 1, it gives you 1. How did we get this 3? 2 multiplied by 2 minus 1. So 2 multiplied 2, that's 4 minus 1, this gave us 3. How did we get this 5? 2 multiplied by 3 minus 1. So 2 multiplied by 3, that's 6 minus 1, that gives you a 5. So the difference between term number 2 minus term number 1, you use 2n minus 1, where n is the first term. So now if we are to find the difference between term number 98 and term number 99, is going to be 2 multiplied by 98 minus 1. And let's simplify that. 2 multiplied 98 minus 1, that's 195. So this difference should be 195. Now what do we do with this 195? We go back to the question. The question says, if T99, so we are going to say T99, if the 99th term of this quadratic pattern is 9,632, find the value of T98, the 98th term. So, and we know that term number 99 minus term number 98 is 195. So we can say t term number 99 minus term number 98 is equal to 195. And we know the value of term number 99. This is 9632. We say minus t98 is equal to 195, which implies that term number 98, if you transfer the term number 98 to the right side and bring the 195 to the left side, it will be 9632 minus 195. So let's take our calculator. 9632 minus 195. This gives us 9437. 9437. So this is the 98th term. So that's it for question 2.2.1. Let's move on to the next part. The next part says, if it is further given that the third term of the quadratic pattern is 32, determine the general term Tn of the quadratic pattern. So we are told that the third term is 32. So we know that our general term of the quadratic sequence of the quadratic pattern is an squared plus bn plus c. And we know that 2a is equal to the second difference. So 2a is equal to d2 for the second difference. We know that a plus b plus c is equal to the first term, t1. And we also know that 3a plus b is equal to t2 minus t1, the first term of the first difference. So now we just need to use these formulas to get our general term. So if we go back here, we know that our second difference was 2. So what this means is 2a. What this means is 2a is equal to 2. And dividing both sides by 2 gives us a is equal to 1. So we already have the value of a. And we know that 3a plus b is equal to t2 minus t1. If we go back here again, we know that t2 minus t1 was 1. So let's go to our equation. 3a plus b is equal to 1. And we already know the value of a. So it will be 3 multiplied 1 plus b is equal to 1. And b would be 1 minus 3, which is negative 2. So the value of our b is negative 2. Now all that we need to find is c. How do we get c? We know that a plus b plus c is equal to the first term. So we can also use this formula. So knowing that the third term is 32, it means if we go back to our pattern, it means t3 is 32. So we can put 32 there. And we know that if we subtract t3 minus t2, we should get 3. So 32 minus 3, this gives us 29. So term number 2 is 29. And also if we subtract term number 2 minus term number 1, we should get 1. So this makes t1 to be 28. Our first term should be 28. So now we go to our equation. A plus b plus c is equal to t1. So a plus b plus c is equal to the first term, which we said is 28. We know the value of a, it is 1. We know the value of b, it is negative 2. We need to find the value of c. So this is 1, minus 2 plus c is equal to 28. 1 minus 2, that's negative 1 plus c. So negative 1 plus c is equal to 28, which implies that c will be 28 plus 1, which is equal to 29. So we now have all the values that we need. A is 1, B is minus 2, and C is 29. Now let's write our general term of our quadratic pattern. So it will be Tn is equal to An squared plus Bn plus C, which is equal to, our A is 1 multiplied by n squared plus our b is negative 2. We put negative 2 multiplied by n plus our c is 29, and let's simplify it into this becomes n squared minus 2n plus 29. So this is the general term of our quadratic pattern. N squared minus 2n plus 29. That's it for question 2.2.2. Moving on to question number 3, we are given a circle with a radius of 6 centimeters is drawn. A second circle, smaller circle, is drawn through the center of the first circle and also touches the first circle internally, as shown in the diagram. So this is the diagram. A third smaller circle is drawn through the center of the second circle and touches the second circle internally. The process of drawing circles continues and forms a geometric pattern. And the first question says, 3.1, write down the radius of the third circle. So they want the radius of the smaller circle. So this is our situation here. So we are told that the radius of the biggest circle here is 6. That's why we put a 6 here. And the blue circle passes through the center of the red circle, which implies that this distance from the edge of this blue circle to where it touches the red circle is also 6, which happens to be the radius of the red circle. So it means this distance here, here's this one, it means this distance is going to be half of 6, which is 3. And then the smaller circle, the black one here, it also passes through the center of the blue circle. So which means the distance from here to where the point where the black circle touches the blue and the red circle, it is 3. So it means from the center of the blue circle to the center of the black circle here, it has to be half of 3, which is 1 over, which is 3 by 2. Since the black circle passes through the center of the blue circle, and the blue circle is a radius of 3, it implies that the black circle has a radius of half of 3, which is 3 over 2, or 1.5. So 3.1 the radius of the third circle is 1.5, or 3 over 2. Moving on to question 3.2, which reads, calculate the sum of the areas of the first 10 circles. So we need to find the sum of the areas of the first 10 circles. So knowing that the pattern of the radius that we have of the radii is forming a geometric pattern. So let's go on and calculate the areas of the first few circles so as to calculate our common ratio of r. So we have the first radius of 6, followed by the second one of 3, and the third one is 3/2 or 1.5. And the area of a circle is found by using the formula pi r squared. So the first one would be pi multiplied by the radius of 6 squared. The second one would be pi multiplied by the radius of 3 squared. The third one, pi multiplied by 3/2 in bracket squared. So simplifying this, 6 to the power 2, that's 36. So the first area of the first circle is 36 pi, followed by 9 squared, 3 squared, that's 9. So the second one is 9 pi. The third one would be 3 squared, 9 over 2 squared over 4. It would be 9/4 pi. Now let's find our common ratio. Our common ratio r would be the second term divided by the first term. Just take any two consecutive terms and divide. The one on the right divided by the one on the left. So 9 pi divided by 36 pi. The pi's will cancel and it will be 9 into 9, 9 into 36, that's 4. So our r, which is our common ratio, is 4. Our n is 10. Our n is 10, and we need to find our a. Our a is the first term, which is 36 pi. So it is 36 pi. And the formula for the sum of a geometric series is Sn is equal to a, which is our first term, into 1 minus r to the power n divided by 1 minus r. Since our common ratio is 1/4, which is less than 1, this is the formula that we should use. Now let's take our values of r, n, and a and plug them into this formula. So S of 10, which is the sum of the first 10 terms in this geometric series, will be a, which is 36 pi, multiplied into 1 minus r, which is the common ratio, 1/4 to the power n. Our n is 10, divided by 1 minus r, which is 1/4. And let's punch this into our calculator. So we have 36 pi being multiplied by 1 minus 1/4, that's 0.25 to the power of 10, divided by 1 minus 0.25, close bracket, which gives us 150.796. So 150.796, which when rounded to 2 decimal places, it becomes 150.80 to 2 decimal places. So that's it for question 3.2. Moving on to question 3.3, it says which circle is a diameter of 3/128. So since this is a diameter, we need to find the radius. So if the diameter is 3/128, the radius would be diameter divided by 2. So when you divide by a fraction, you simply multiply and you invert the fraction. So this is the same as 3/128 multiplied by 1/2, which will be 3/256. So this is the radius. And let's go back to the sequence of our radius. So we have 6 as the first term, followed by 3, followed by 3 over 2. And we want to find which circle has got this radius of 3 over 256. So let's try to find the general pattern, the general term of the sequence of the radii. So we know that the Tn, the general term of a geometric series, of a geometric pattern rather, is a into r to the power n minus 1, where a is the first term. So we want to find Tn with our a as 6. If we go back here, our a is 6, so we are going to replace 6. And our common ratio r, in this case, since we are using the radius, we have to find the common ratio first, and our common ratio will be 3 divided by 6, which gives you 1 over 2. So our r is 3 over 6, which is 1 over 2, or 0.5. So now let's punch in 0.5 there, and then to the power n minus 1. So we want to find n, so to the power of n minus 1. And we know this should give us 3 over 256. So we are going to put 3 over 256 on the left side, being equal to 6 multiplied by 0.5 to the power n minus 1. And this can be solved in different ways. So let's get rid of this 6 first by dividing both sides by 6. So we can divide this side by 6 and divide the left side by 6. And since we are dividing by a fraction, it is the same as multiplying by 1 over 6. So it's going to be, the 3 will cancel, into 6, 3 divides 6 2 times. So the left side will be 1 over 256 being multiplied by 2, being equal to, this 6 will cancel with this 6, so we're going to have 0.5 to the power of n minus 1. And we can apply logarithms. Let's apply logarithms on both sides. So we are going to have the logarithm of 1 over 256 multiplied by 2, that's 512, being equal to the logarithm of 0.5 to the power of n minus 1. And using the laws of logarithms, the right side, on the right side you can bring down the exponent. So the right side would be n minus 1 being multiplied by the logarithm of 0.5. And on the left side, we still have the logarithm of 1 over 512. Which means if we divide the logarithm of 1 over 512 divided by the logarithm of 0.5, this should give us n minus 1. And solving this implies that the left side can be written as the logarithm of 1 over 512 with a base of 0.5, with a base of 0.5 being equal to n minus 1. So being equal to n minus 1, and solving for n would be equal to, let's transfer the negative 1 to the other side. So n would be 1 plus the logarithm of 1 over 512 with a base of 0.5. And punching this in our calculator, and punching this 1 plus the logarithm of 1 over 512 with a base of 0.5 in our calculator gives us a value of n equal to 10. So it is the 10th circle with a diameter of 3 over 128. That's it for question 3.3. Moving on to question number 4, where we are given a function f of x which is equal to a to the power x minus 1 for a is bigger than 0, and we have a point B with coordinates 2 for x and minus 5 over 9 for y, being at a point on the function f. The first question goes on to say, calculate the value of a. So to calculate the value of a, we need to replace the value of x with 2 and the value of y, which is our f of x, with minus 5 over 9. So we are going to replace our y with minus 5 over 9 and equate it to a to the power of x. Our x is 2, negative 1. And let's solve this. Let's transfer negative 1 to the left side. It will be negative 5 over 9 plus 1 is equal to a to the power of 2. Simplify the left side. 1 can be written as 9 over 9. So 9 minus 5, that's 4, with a common denominator of 9, being equal to a to the power of 2. Now let's find the square root on both sides. So let's find the square root there, and also on the left side. The right side will simplify into a, and we have the square root of 4 over 9, which is plus or minus 2 over 3. But because our value of a here, it says it has to be greater than 0, it has to be positive. So this implies that our a has to be positive 2 over 3. And we drop down the negative 2 over 3 because a has to be positive. That's it for the first point, 4.1. Let's move on to the next part. The next point, 4.2, says write down the range of function f. So since now we know the value of our a, we can rewrite our function as f of x is equal to 2 over 3 in bracket to the power x minus 1. So since the value of a is between 0 and 1, this implies that our graph is decreasing. Our graph will be decreasing. And since the value of a is between 0 and 1, this implies that our graph will be decreasing. And also, since the sign of a is a positive sign, it makes our graph to decrease, which Now let's move on to question 4.3, which says, sketch the graph of f, clearly show the intercepts with the axis and asymptotes, if any. Now, our function is f of x is equal to 2 over 3 to the power of x minus 1. So let's create a table with a few values of x. So we are starting from x is negative 2 to positive 2. You can choose any values of x that you wish to start from, and plugging in negative 2 where there is x will give us 1.25. Replacing x with negative 1, 2 over 3 to the power of negative 1 minus 1 will give us 0.5. Replacing x with 0 will give us 0. Replacing x with 1 will give us negative 0.33. And replacing x with 2 will give us negative 0.55. So this should be enough for us to draw our graph. Now the first thing that you need to do is to draw your asymptote. So in every exponential function, the constant term that you have, if there's any, the constant term, which in this case is negative 1, is your y asymptote. We don't have an x asymptote in an exponential graph. So in this case we have negative 1. That's why we have drawn a blue dotted line on y is negative 1. If there was no number here, in other words, if our constant was 0, the y asymptote was going to be the x-axis. So in this case, we have negative 1 is our y asymptote. Now let's plot in these points. The first point is when x is negative 2, y is 1.25. So negative 2 for x is around here, and 1.25, let's say somewhere there. When x is negative 1, y is 0.5. When x is negative 1, y is 0.5. So somewhere there. When x is 0, y is 0, so our graph passes through the origin. When x is 1, y is negative 0.33. So 1 and negative 0.33, let's say somewhere there. And when x is 2, y is negative 0.55. Let's say somewhere there. And we can plot our graph. It will be something similar to this. And we can put our arrows. And we know that our graph does not touch the asymptote. So our y asymptote is y is negative 1, and our x intercept is 0, 0. That's it for question 4.3. Moving on to 4.4, it says it is further given that C is a point on the function f at y is 19/8. Determine the coordinates of C prime, the image of C, when C is reflected about the line y is equal to x. Now to answer this question, we first have to find the coordinate of C, which is x and 19/8. So we need to find the value of x first and then reflect this point in the line y is equal to x. So how do we find the x coordinate of point C? By replacing the y value in the function f of x is 2/3 to the power x minus 1. So we replace the y value with 19/8. So it will be 19/8, which is our y, or f of x, being equal to 2/3 to the power of x minus 1. And then we transfer x to the other side. We transfer negative 1 to the other side. It will be 19/8 plus 1 is equal to 2/3 to the power of x. And if you add 19/8 plus 1, 1 can be written as 8/8. So 19 plus 8, that's 27/8, being equal to 2/3 to the power of x. And we can apply the logarithms on both sides, and it will be the logarithm of 27/8 being equal to the logarithm of 2/3 to the power of x. And the right side will be the logarithm of 2/3 to the power of x. So we bring down the x first. It will be x, the logarithm of 2/3. Now dividing both sides by the logarithm of 2/3 will give us, so we're going to have on the left side the logarithm of 27/8 being divided by the logarithm of 2/3 being equal to x. And this can also be written as the logarithm of 27/8 with a base of 2/3. Punching this in our calculator will give us x as -3. So this is our value of x. of negative 3. So this means point C has got coordinates negative 3 and the y value that we were given 19 by 8. So 19 over 8. Now, since the question says point C was reflected in the line y is equal to x, when you reflect any point in the line y is equal to x, you get the inverse of that point. In other words, you interchange x with y. So C prime, we have the coordinates, just interchange these points here. Our x becomes 19 over 8 and our y becomes negative 3. So this is our C prime. That's it for question 4.4.